Hello friends, my name is Meenakshi and in today's class we will see about surface areas and volumes of class 10. Now let us go into the lesson. Now what do you see in this picture? This is a cube. In this cube you have what is the this is a cube where this side is the side of the cube. In a cube all the sides are equal. Okay, now let us go into the curved surface area of the cube. What is the curved surface area of the cube? Curved surface area of the cube is 4a squared and the total surface area is 6a squared. Before going into the total surface area, we will see the curved surface area. So in the curved surface area, we do not include the top and the bottom surfaces, only the curved portion. That is, uh, this full distance is this curved portion. This full four sides are included. So you get 4a squared. That is you get all the four sides excluding the top and the bottom. So the side of the cube is a centimeter. So you have the length and the breadth. So it is a squared. So there are four squares. So you have 4a squared. So that is how we calculate the curved surface area of the cube. Now let us go to the next one, that is the total surface area. The total surface area, we include the top and the bottom surfaces also. So how many faces does a cube have? A cube has 6 faces. So the total surface area of a cube is 6a squared. Now we'll go to the formula for the volume. Formula for a volume of a cube is a cubed. Now what do you mean by volume? Volume is the total capacity that a cube can hold. So it is given by a cubed. There are three dimensions for a cube. The length, the breadth and the height. All the three are equal in a cube. So you have a cube. So in this we come to know the curved surface area, the total surface area, the volume of a cube, where A is the length of the side of the cube. I hope all of you would have understood this. Now let us go to the next figure. This is a cuboid. Now in a cuboid, you have the width, the length and the height. Okay, how many faces does a cuboid have? A cuboid has 6 faces. Now let us go and see the curved surface area of a cuboid. The curved surface area, we do not take into consideration there are only the 4 faces of the rectangle is taken into consideration. Therefore, what is the formula for the curved surface area of a cuboid? It is 2h into L plus B. That is HL, height into length. So this face, the face opposite to it will have height into length. So 2HL you have and 2HB, height into breadth. Okay. So that is how we have the formula for the curved surface area of a cuboid. It is 2H into L plus B. The base, the breadth and the height is not taken into this part. the breadth and the height is not taken into consideration. Okay. I'm sorry, the length and the breadth is not taken into consideration. The top two faces, the top and the bottom faces are not taken into consideration. That is the length and the breadth. Okay. So now we'll go to the total surface area of a cuboid. It is 2 into LB plus BH plus HL, where L is the length, B is the breadth, and H is the height. Here, all the 6 faces of the cuboid is taken. That is, how many faces does a cuboid have? It has 6 faces. The top and the bottom 2 faces and the 4 faces on all the 4 sides. So, we have 2 into LB plus BH plus HL. Whereas in the curved surface area, we had left the top and the bottom. That is the LB part, 2 LB was left. Okay. Now we'll go into the volume of a cuboid. Volume of a cuboid is given by length into breadth into height. Volume gives us the capacity of the cuboid, the how much quantity it can hold. Okay. I hope you understood all the dimensions of a cuboid. Now let us go to the next figure. Now we go into a cylinder. Now let us see what are the, this is a cylinder. Okay. So here first we have the curved surface area of a cylinder. So what do you mean by curved surface area? This part fully is called the curved surface area. Okay. So here this is the radius of the cylinder, and this is this part here. This is the height of the cylinder. So now the what is the formula for the circle? Now what is a cylinder? A cylinder is nothing but it has a circular face on the top and a circular face at the bottom. The full structure of a cylinder is nothing but layers of circular planes. Okay, if you are going to add up lot of circular surfaces, it will come up to a cylinder. Okay, so 2 pi r h. 2 pi r is the circumference of the circle and h is the height of the cylinder that you draw. Okay, this is the height. So 2 pi r h is the curved surface area of a cylinder. Now what is the total surface area? Total surface area is 2 pi r h plus 2 pi r squared. That is this area, this circular area that we have on the top and the circular area that we have at the bottom. That is called as the, what is the area of this circular surface? The area of this circular surface is pi r squared. Similarly, for the bottom also you have another circular surface over here. The area of this is pi r squared. Therefore, on the whole, the total surface area is 2 pi r h plus pi r squared plus pi r squared. It is 2 pi r squared. I hope you understood this. Now we'll go to the volume of a cylinder. It is pi r squared into h. Now where r is the radius and h is the height. I hope you understood everything. Now we'll go to the next one, that is the right circular cone. So in a right circular cone you have the curved surface area. So this is the curved surface area of the cone. It is given by the formula pi r L. Now what is L? L is this slant height. This slant height is the L. Now how is L given? L is given by root of r squared plus h squared. Now let us look at this figure even nicely. Now let us look at this figure even better. Yes. Now let us look at this figure. You have, this is called as the slant height, isn't it? Hmm? So it is given by root of r squared by h squared. So this is a right angle triangle. H and r is a forms a right angle triangle. So L is given by root of r squared plus h squared. Now let us go to the next formula, that is the total surface area. Total surface area of the cone is pi rl plus pi r squared. That is this pi rl, that is a curved surface area, plus the area of the bottom, which is a circle. What is the area of a circle? Pi r squared. So pi rl plus pi r squared gives us the total surface area. When I take my pi r outside, I have pi r into L plus R. Okay. Now let us go to the next formula, that is the volume. Volume is equals to 1 by 3 pi r squared h. Volume is the capacity of the cone, where r is the radius and h is the height, and pi is equals to 22 by 7 or 3.14. Now let us go to the next figure. Now in this we will see a sphere. Now, what is the curved surface area of the sphere? It is 4 pi r squared. A sphere is nothing but a three-dimensional view of a circle. Okay. So, if you take the earth is a sphere. An example for a sphere is the earth. Now, the total surface area is also equal to 4 pi r squared in a sphere. Now, what is the formula for a volume? It is 4 by 3 pi r cubed, where r is the radius of the sphere. Now, let us go to the next one, which is a hemisphere. So, in this hemisphere, the curved surface area is given by the formula 2 pi r squared. So this full area, the curved surface of this full area is 2 pi r squared, whereas the total surface area will include the top circular region. So you have 2 pi r squared plus pi r squared is 3 pi r squared. That is the total surface area of a hemisphere. The volume of the hemisphere is given by the formula 2 by 3 pi r cubed. Now let us go to the next figure, which is the frustum of a cone. Now what do you mean by frustum of a cone? Here in this figure, we will see a cone. A cone, when it is sliced by a plane that is parallel to the base, you get two figures or two parts. In that, this one part is called the frustum of a cone. So here, this is how a frustum will look. It looks like an inverted bucket. Okay. So you have two radiuses, R1 and R2. Here in this figure, we have the lower one is the R1 and the upper one is the R2. And S is the L is the slant height and this is the other height. Okay. Now, curved surface area is equal to pi rl, isn't it? Here r is r1 plus r2, the upper radius and the lower radius. Okay, so it is pi l into r1 plus r2, where l is equal to, the slant height is equal to root of h squared plus r1 minus r2 the whole squared. Here we have a squared. Okay, r1 minus r2. Here this is R1, that is this is R1 and the lower circle is R1, the upper circle is R2. The total surface area of the frustum of a cone is pi into R1 plus R2 into L plus pi R1 squared plus pi r2 squared. That is this top circular region and the bottom circular region along with the curved surface area of the frustum. I hope you understood this. Volume of the frustum of a cone is 1 by 3 pi h into r1 squared plus r2 squared plus r1 into r2. Here h is the height and L is the slant height. I hope you all understood this. Now we'll go to the first question. A cylindrical pencil sharpened at one edge is the combination of, now this is a pencil, okay. Now that is a combination of two figures. What are they? Two shapes, okay. So what are they? A cone and a cylinder, a frustum of a cone and a cylinder, a hemisphere and a cylinder, or two cylinders, okay. Now let us see the answer. The solution is a cone and a cylinder. How do you say that? See, in a pencil, this part resembles a cylinder, whereas the pointed tip resembles a cone. So it is a combination of a cylinder and a cone. Okay, now let us go to the next question. A surahi is a combination of a spear and a cylinder, a hemisphere and a cylinder, two hemispheres, a cylinder and a cone. Now, what is a surahi? A surahi is a pot. Okay. So, now the answer is it is a combination of a spear and a cylinder. So this is how a surahi looks. It consists of a spear and a cylinder. Okay. Now let's go to the next one. A plumb line or a sahul is a combination of a cone and a cylinder, a hemisphere and a cone, frustum of a cone and a cylinder, or a spear and a cylinder. The answer is it is a combination of a hemisphere and a cone. What is a sahul or a plumb line? It is used to find the depth of water at any point. It resembles a top, okay? Top which we play, isn't it? Toy top. So what is it? It is a combination of a cone and a hemisphere, okay? I hope you understood this. The shape of a glass or a tumbler is in the form of a cone, a cylinder, frustum of a cone, or a sphere. So here, what does a tumbler resemble? A tumbler resembles a frustum of a cone. Okay. So this is an inverted shape of a tumbler. Now this resembles the frustum of a cone. Okay. Let's go to the next question. Here, in this question, let us read the question. Two cubes, each of volume 64 centimeter cubed, are joined end to end. Find the surface area of the resulting cuboid. So here you have two cubes whose volume is given as 64 centimeter cubed and they are present one over the above. So you get to the problem. Here, given volume of the cube is equal to 64 centimeter cubed. So A cubed is equal to 64 because the side of the cube is given by A, isn't it? So A cubed is equal to 64 centimeter cubed. Therefore, A is equal to 4 centimeter. If A cubed is 64, A will be equal to 4. Cube root, you take the cube root of 64, it is 4. Okay. Now, you will see here that the length and the breadth of the cuboid remains the same, whereas only the height of the cuboid varies and the height is given by 8 centimeters. Okay, that is 4 plus 4, 8 centimeter. The sides of the cuboid formed by joining the cubes have dimensions of 4 centimeter, 4 centimeter and 8 centimeter. Therefore, surface area of the cuboid is 2 into LB plus BH plus HL, which is nothing but 2 into, what is L and B? It is 4 into 4. BH is 4 into 8 and HL is 8 into 4, because height is 8 and L is 4. So we will multiply them and we will calculate the value. It is 160 centimeter squared. Hence, surface area of the resulting cuboid is 160 centimeter squared. Now let us go to the next question. Now, the next question we will see, a vessel is in the form of a hollow hemisphere. So, this is the hollow hemisphere. It is mounted on a hollow cylinder. Now, this is the hollow cylinder. The diameter of the hemisphere, this full length of the hemisphere is 14 centimeter and the total height of the vessel is 13 centimeter. Find the inner surface area of the vessel. So first, this is a combination of two shapes. Okay. So first, when the diameter of the hemisphere is 14 centimeter, this height of the sphere will be 7 centimeter, and even here it will be 7 centimeter. So let us see how we solve this problem. Given radius of the cylinder is equal to 7 centimeter. I hope you understood how we got the radius of the cylinder. It is given half of the hemisphere's diameter will give me my radius of my cylinder. Okay, it is 14 by 2, 7 centimeter. What is the height of the cylinder? The total height is 13 centimeter. If I subtract 7 from it, I will get 6 centimeters. Okay. Therefore, radius of the hemisphere is also 7 centimeter. Now, the inner surface area of this figure or of this vessel is nothing but the curved surface area of the cylinder plus the curved surface area of the hemisphere. So, what is the curved surface area of a cylinder? It is 2 pi r h. The curved surface area of a hemisphere is 2 pi r squared. For pi, we will substitute the value 22 by 7. So, when you calculate it, you have 2 into 22 is common in both the terms. We bring it out. We have 6 plus 7 or 44 into 13 is equal to 572 centimeters squared. I hope you understood how we solve this problem. Now, that is all for today's in this slide. Thank you friends. Thank you for watching.